Today we're going to practice solving some basic two-step equations through solving the problems on this worksheet right here. And before we get started with it, I want to make sure that you guys have a piece of paper in front of you. Okay, well, aside from the worksheet, so you should have the worksheet. You should also have a piece of notebook paper, and you should go ahead and label it now, your work, Miss Popelka's work, and whether or not it matches. The expectation while you are watching this video is that as soon as the problem comes on the screen, you'll pause it, try to work it on your own. Your work will, of course, go right here where it says your work. See how I have the problem number? And then if this were my paper, I would write my work. Then next to it, you're going to start the video and watch me work it. Put my work down in the middle. And then I'd like you to say yes or no. Does your work match mine? And if it doesn't, what is different? So again, every single time the problem pops up on the screen, you'll pause the video, try to work it yourself. Remember, even if you miss it, it's okay. You really do learn it better by examining your mistakes, even if you mess up the whole thing. Comparing your work to my work will help you to learn it better. So you need to put your work. Then, where it says Miss Popelka's work, you'll actually put what I do. Then again, in this third part of the page, you'll put whether or not it matched. So this is for a grade. It will not be accepted without having all three of those pieces. Now, on to the fun stuff. Okay, the first problem that we had to work was 5 plus 2x equals 25. For those of us that are more visual, I've made a model down here at the bottom of the problem. You'll recall from class that on our algebra tiles, the blue long ones are x's, and that each one of these green pieces is a 1. So this is a model of 5, didn't mean to do that, 5 plus 2x is equal to 25. So if you need the model, it's here to help you. Go ahead and pause the video and try to work it yourself, then restart the video when you're ready. I'm assuming that you've paused the video and that you've worked it yourself and you've shown your work on your separate sheet of paper. I'm going to go ahead and work the problem. So remember that our ultimate goal whenever we're solving an equation is that we want to isolate the variable, that is, get it by itself. Fancy word for that is isolate it. In order to do that, we're going to end up with an x on one side of our little balance beam and a number on the other side of our balance beam. That tells us how much does the x weigh. So in order to get it isolated, I've got to use inverse operations. Remember, inverse is our fancy word for opposite. So let's see what I can do here. So I've got, first of all, that x is definitely not isolated. It's got a 5 hanging out with it, and there's actually 2 of those x's. So there's not just one. The first thing I'm going to do is remove the 5 from the left side of my balance beam. On paper, this is what it should look like. To get rid of that 5, I'm going to subtract 5 or add a negative 5, depending on how you think about it. Now, if this were real life and this were really a balance beam, my balance beam would now be out of balance because I took 5 away from the left side of my balance beam, but I haven't done the same to the right, so I've got to do the same to the right. So I'm going to take away 5. 25 minus 5 means that I'll have 20 units left over here. Those 5s are now gone, but I still have those 2 x's. So now I've got 2 x's on one side and 20 on the other. So a lot of you guys in class have been trying to get rid of this 2 by subtracting. Remember that when the 2 is sitting next to the variable, that means multiplication. What is the inverse of multiplication? Well, hopefully we know that that is division. And what that means is you're literally taking these 2 x's and you're dividing them up into 2 groups. I'm going to build kind of a little wall right in between them. So I'm taking these 2 x's, I'm dividing it by 2, that'll cancel out that multiplication, and then now in each group I just have 1 x. So again, I did the inverse. I had 2 times x. I undid that by dividing by 2. That left me with an x. Now if I split up everything in half on this side, I need to do the same over here. So I'm going to divide this side in half. 20 divided by 2 means that I'll have 10 in each group. This group here at the top has 10. This group in the bottom has 10. Therefore, 1x is equal to 10. So my final answer should have been x is equal to 10. I know I'm done because that x is all the way isolated and it's set equal to a 10. The coolest thing about equations is that I can actually go back and check my answer. So I'm pretty sure that x is equal to 10. So instead of 5 plus 2 times x, down here I'm going to do 5 plus 2 times 10, since I'm pretty sure that x is equal to 10. 2 times 10 is 20. 20 plus 5 is 25, which is exactly what I have on this side of the equation. So I know for a fact that I did it correctly. Number 2, pause the video, try to work it on your own, and then restart the video when you're ready. I am going to go ahead and assume that you've taken that step, and I'm going to work it myself. So I've got 4x plus 11 is equal to 23. I've made myself a model with my 4 x's, my 11 units on one side of my balance beam, 23 on the other side. The first thing I'm going to do to isolate this variable is I'm going to get rid of that 11. Just take it away. So I subtract 11 here, which means that that will cancel. Leave me with just the 4 x's that I have remaining on the left side of my equation. Of course, now it's out of balance. I took away 11 from this side, but I haven't taken away 11 from this side. So let me do this. 8, 9, 10, 11. So if I counted correctly, this should leave me with 12 left over. Yep. So now those x's still aren't isolated. I need to get these 4 x's into separate groups, but to isolate them. So the opposite of multiplying x by 4 is, of course, to divide by 4. So I'm literally taking these 4 x's and I'm dividing them up into 4 separate groups. So if I take those 4 x's and divide them into 4 separate groups, how many x's are in each group? There's 1 in each group. So this is going to cancel, leave me with an x. Of course, if I divided the left-hand side into 4 groups, I've got to divide the right side into 4 groups. So if I do that, there's 12 over here. So 12 divided by 4 means that I should have 3 in each group. Let's double check. So there's a group, and there's a group, and there's a group, and there is my 4th group. So I know, in fact, that x is equal to 3. Again, I can double check my answer just to make sure. Instead of 4 times x, I'm going to do 4 times 3 and get a 12. 12 plus 11 is, in fact, the 23 that I was looking for up here. So I know that I did this problem correctly. Number 3. Now this one looks a little bit different from some of the other ones that we've seen, but that's okay. Just like you can subtract numbers from both sides of the equal sign like we did in the past, you can also subtract variables from both sides of the equal sign. So because right now we're looking, and I'm just giving you a clue before you pause the video, we want something that has an isolated x on one side and a number on the other side. But right now, we've got a variable on both sides. So one of those variables has got to go. So that's the clue I'm going to give you. Then go ahead and restart the video in just a moment and check yourself after you've tried it yourself. I'm going to go ahead and go on, though. I'm going to go ahead and really, I could get rid of this, of the 3 x's or the x, but I'm going to go ahead and get rid of this single x right here. And the reason for that is, since in order to be able to solve this equation, I want to end up with a variable on one side and a number on the other. If I get rid of this 3x, then I don't leave anything over on this side. But if I get rid of this x, then I've got a variable on one side and a number on the other. So it just seems to make more sense to me. So I'm going to take this x and, now he's gone, taking him away. So that is going to look like this. To get rid of that x, I added a negative x or subtracted an x, however you want to think about it. Again, just like numbers, if I subtracted and took away an x from this side of my balance beam, I got to do the same thing over here. So 3x minus x means now I'm going to have 2 x's left over. I've still got a 16 over here on my left-hand side. So now I've got 2 x's that are equal to 16. So I've got to, as in the previous 2 examples, undo this multiplication by dividing. That's going to leave me with just 1 x, because if I take these 2 x's and divide them into 2 groups, that's going to leave me with 1 x in each group. If I divided this side in half, I've got to divide this side in half into 2 groups. 16 divided by 2 is going to give me 8. So that means that x is equal to 8. I can tell because now I've got 1x on one side set across from 8 on the other side. But I can also double check it and just check it just to make sure. So instead of 3 times x, I'm going to do 3 times 8, which is 24. And on the other side, instead of doing 16 plus x, I'm going to do 16 plus 8. 16 plus 8 is in fact 24. Both sides balance, so I know in fact that x is equal to 8. Number 4, take a moment. As before, pause the video, try to work it yourself, restart the video once you're ready to check it. So I've got a variable on both sides again. I'm going to go ahead and, for no particular reason, and just get rid of this x, just because I feel like it's easier to get rid of 1 x rather than 2 x's. So this x is gone bye-bye. However, it's unbalanced now. If I take an x from over here, I have to take an x from over here. So now this is gone. And on the left-hand side of my equation, I have a 9. On the right-hand side, 2x take away x is going to leave me with just 1x. And that 4 is still there. So I've got a 4 plus x over on the right-hand side of my equation. There's my x, there's my 4. I'm going to get rid of this 4 by subtracting 4 to further isolate my variable. If I take 4 away from here, got to take 4 away from here. 9 minus 4 is 5. 5 is equal to x. Number 5, try it out. I'm going to go ahead and work it though. So I still need to get this x isolated, which means the first thing I'm going to do is ditch this 7. If I take away 7 over here, got to take away 7 over here. This is what it would look like on paper, of course. I took away 7 from here, so I'm going to take away 7 from here. That's going to cancel. So I've still got my 3 x's on the left side of my balance beam. 10 minus 7 means I'm going to have 3 on the right side of my balance beam. So now I've got to take these 3 x's and literally divide them into 3 groups. If I do that, that means each group is just going to have an x left over. I divided this side into 3 groups, so I got to divide this side into 3 groups. How much will be in each group? Well, 3 divided by 3 means that there is 1 in each group. So x is equal to 1. I'm going to start going a little faster now, and if you need to use the model, it's here for you, but I'm going to go ahead and do more. Well, no, that's not true. I'll probably still go ahead and use the model too, but just in case you need it. So again, I'm trying to isolate this variable, get the x by itself. I got to get rid of this 5 first. So I'm going to get rid of that 5. Of course, if I get rid of 5 over here, got to get rid of 5 over there. So if I take away 5, that means all I'm left with on the left side of my equation is 3x. Over on the right side of my equation, I've got 33. Well, if I take these 3 x's and divide them into 3 groups, that'll cancel out this multiplication. Each group is going to have 1 x left in it. 33 divided by 3. If I divide this side by 3, I got to divide that side by 3. So that is going to be equal to 11. If I were to divide this group up into 3 groups, I would see that 1x is equal to 11. Actually, let me clean this up a little bit just so that the part on paper looks a little more neat. Get rid of this for a second. Just to make sure. All right, so I subtracted 5 from over here, and I subtracted 5 from over here. So that left me with 3 x's on the left-hand side and 33 on the right-hand side. To undo this multiplication, I'm going to divide by 3, which is going to cancel, leave me with an x. I divided that side by 3, so I divide that side by 3. X is equal to 11. I can double check myself too, just to make sure. Instead of 3 times x in the original problem, I'm going to do 3 times 11, since that's what I'm pretty sure it's equal to. So 3 times 11 is 33. 33 plus 5 is 38, which is equal to what I have on the other side. So I know I did it right. Again, I'm going to start going quite a bit faster now. So to isolate my variable, I'm going to get rid of this plus 6 by subtracting 6. That is going to leave me with 4 x's over here and 24 over here. So let me get rid of my 6. Let me get rid of 6 more over here. Now, as I did before, I need to get to further isolate these variables. I need to take those 4 x's, divide them into 4 groups. Each group is going to have an x in it. If I divided this side by 4, I've got to divide that side by 4. So this 24 do I have more down there? Oh yeah, I've got more down there. Okay, so if I take this 24 and divide it into 4 groups, each group would have 6 in it. So 6 is equal to x. Again, I can double check my answer. Instead of doing 4 times x, I'm going to do 4 times 6, since that's what I'm pretty sure it's equal to. 4 times 6 is 24, plus 6 is 30, which is equal to what I have over there on the other side. So I know that I did it correctly. And sorry, I just realized that changed the ink color, so hopefully that didn't confuse you that, that all of a sudden that 6 turned green for some reason. So again, I subtracted 6 from both sides. That left me with a 4x, and 30 minus 6, which is 24, divided each side by 4. Number 8, I've got one of those pesky variables on both sides again. In case you need another visual, I did make a model of this one too. I'm going to go ahead and kind of work it. So I'm going to go ahead and get rid of this x right here, just because I think it's a little easier to get rid of one x than it is to get rid of 6 of them. So that's going to cancel. I'm going to take an x off of this side. So if I take this x away, and if I take one of these x's away, that is now going to leave me with a 13 on the left side of my equal sign is equal to 6x minus x is a 5x plus 3. So right now, after taking an x off of both sides of my equal sign, I've got 13 on one side, and then I've still got 5x's plus 3 over here on the other side. I'm going to scoot one of these x's down just a little bit. I didn't give myself enough room to work. There we go. So now I've still got to get this x isolated. I still need to get it by itself. A lot of you guys in class were taking a step where you were getting rid of the number that is on the side of the equal sign by itself. That doesn't help you to get that x isolated. You need to get rid of the 3 and the 5 that are with the x. So we need to get rid of this 3. So I'm going to chop off that 3. If I chop off 3 from this side, of course, I have to do the same over here. So if I take away 3, that's going to leave me with 5 x's on this side. If I take away 3 from over here, I've got to take away 3 from over here. 13 minus 3 is 10. So now I've got 10 on the left side of my equal sign, and I've got 5 x's over here. Well, if I take these 5 x's and I divide them by 5, of course, each group is going to have 1 x in them. If I divide it into 5 groups, 5x divided by 5 is just going to be 1x in each group. If I divide this side by 5, I've got to divide this side by 5, so 10 divided by 5. So if I divide this 10 into 5 groups, there's 1, 2, 3, 4, and 5. 10 divided by 5 is 2, so that means that x is equal to 2. Let me do this one more time without the model this time. I know for some people that really helps them. For some people, they don't really like it. So let's try that one more time. Okay, so I can't have an x on both sides of my equal sign. So I got rid of an x over here. If I subtracted x from this side, of course, I've got to subtract x from this side. 6x minus x is 5x plus 3. I'm going to bring down my 13. Get rid of adding 3 by subtracting 3. The reason I decided to get rid of this 3 is because I need this x by itself, which means I got to get rid of that 3 and that 5. So I subtracted 3 over here. So I'm going to subtract 3 over here. 13 minus 3 is 10. Then undo that multiplication by dividing. 10 divided by 5 is 2, which is equal to x. Number 9, try it out yourself. I'm going to go ahead and work it though. And actually, I don't think we need these so much anymore. I don't think we need all this. Okay, so first of all, I want to get that x by itself, which means I need to get rid of the 8. So I'm going to get rid of an 8 with a minus 8. That'll cancel. I've still got 5 x's on the left side. I took away 8 over here, so I take away 8 over here. 53 minus 8 is 45. I've got to undo this multiplication by dividing by 5. That's going to leave me with an x. I divided that side by 5, so I'm going to divide that side by 5. X is equal to 9. Number 10, again, I've got one of those pesky problems where I've got a variable on both sides of my equal sign. I'm going to go ahead and get rid of this one right here, again, because I think it's easier to get rid of one x than it is to get rid of 2 x's. I subtracted an x over here, so I need to subtract an x over here. 2x minus x is an x. Still got my plus 1. Bring down your 13. That x isn't all the way isolated. We still got to get rid of this extra 1 by subtracting a 1. That's going to leave us with just an x over here. If I subtracted 1 from over here, got to subtract 1 from over here. 13 minus 1 is 12. 12 is equal to x. Number 11, again, I need this x isolated. I'm going to start off by getting rid of this 4. If I subtracted 4 from over here, I need to subtract 4 from over here. 56 minus 4 is 52. That 13x is still around. To undo this multiplication, I'm going to divide those 13 x's into 13 groups, which will leave me with just one x. I divide this side by 13. So I'm going to divide that side by 13. 52 divided by 13 is 4. So 4 is equal to x. Last but not least, again, I've got variables on both sides of my equal sign. I'm going to get rid of this one just because I think it's easier to get rid of one x than it is to get rid of 3. That's going to leave me with a 15. I subtracted x from this side, so I'm going to subtract an x from that side. 3x minus x is 2x plus 1. Now I still need to get this x isolated. It's not by itself. So I need to get rid of this 1 by subtracting 1. That's going to leave me with 2x's over here and 14 over here. Get these models out of the way here. So that 2x means 2 times x. How do I get rid of multiplying by 2? Of course, I do the inverse, which is to divide, because division is the opposite of multiplication. That's going to cancel, leave me with an x. I divided this side by 2, so I'm going to divide that side by 2. X is equal to 7.